do it. Yeah. So now I'm drawing the picture, and this is your O, and just let me check the labels. Yeah, it's A, and this is C. Yeah. So A is yes.
No, sir.
So yeah, A is the center for this circle, the new circle, and O is the center for the first, right? And C is where they intersect, sort of. So that's what they meant by taking A as a center and drawing this arc, right? So in their picture, they did not have this. They didn't draw this circle. I mean, they didn't draw the full circle. Means, but we can draw it, right? Then what's the other thing? We draw this line. And we want this ADC. So the radius you can actually take to be anything. So in this kind of question, you can understand, right? That the radius does not matter, right? The answer, the angle would still come out to be the same, whatever radius you take, right? Because changing the radius would just be like magnifying the figure, but that will not change the angle, right? If you just magnify uniformly everywhere, just expand it. So you can assume that the radius is 1. So you can use that maybe. Right? So both the circles, in fact, have radius 1. Now this problem is a little interesting. Let's draw these things. So you can see that this AEO is equilateral, right?
Yes, sir.
It's equilateral,
Yes.
right? And also it's already given that this is 90 degrees. That is there. So can you say that this is also 90 degree, the place where I marked 90 degree,
Yes, sir.
right? It's fine. I mean, just maybe go later on, you can try to prove it actually, but for now it's sure that this is 90 degree. I think this is a little interesting question. If you can't find the angle, then try finding all the lengths. Maybe that may help. Any ideas? So can you tell me what is EX? You know what is EX, you can tell me.
The radius.
No, EX. EX. Why
Oh, it
should
is the
EX?
perpendicular.
Yes, yes. It's perpendicular to, this is an equilateral triangle. So length of the perpendicular should be root 3 by 2, right? You can calculate it. Because you see this will be half, right? So maybe before that AX is half. That is also clear. So from there you can figure out this EX, root 3 by 2. Does that help? So EX is root 3 by 2, then obviously CX is also root 3 by 2. Can you now find DX or something? Like, look at this. BOD, look at BOD and look at CXD. They are similar, right? Right? Because they have the same angles, right? BOD is 90, CXD is 90. Then you can see the CDX and PDO, they are both the red angles, they are both equal. So they are similar. So you can exploit that, right? So this BO by OD, right? BO by OD should be equal to, so can you tell me what I should write here by similarity? It's CX by XD, right? Yes. Do you remember have you done similarity properly?
Yes, sir.
Hmm? So first my question is, are you able to see that these two triangles are similar, right? So similar is just the word, just the, means you can see that the triangles have the same angles, right? If you isolate it here, just draw it here, right? This triangle, and then you look at this triangle, this situation, right? Whenever you see this situation, these are 90, these two are similar, right? Because these angles become same, they are straight lines. So they are similar, right? So what does it mean? It means that this by this, right, the ratio of the perpendicular and base should be same as the ratio of the perpendicular and base of this one, right? And so I will write Cx by xt. If this is okay, then you can now tell me what is OD. Because you also know that OX is half, right? OX and AX are same, that's half. Just put the numbers and just put BO and OD and then you'll get, right? I want you to do it yourself. I mean, you can do it, but I know, but just try to do it now. And I have to see if there is any, if you want me to go over similarity once again, that would not be a bad idea. I mean, if you think you need, I need to, otherwise. Hey, what happened? Um,
So like I can't understand how to like further.
Okay, so till here it is fine, this ratio.
Yes, sir.
Okay, now you just put the value. So what is BO? 1, OD, we don't know, we want to find. CX, CX we found is root 3 by 2. DX, we don't know. Okay, this, right? So what do we get? We get that DX by OD is equal to root 3 by 2, right? But you know that DX plus OD is what you know. So what is DX? So ratio of two numbers, right? DX plus OD is, it is half, that is OX, it is half. So you can just calculate now. So OD plus DX, that is half, and this, right? And this is half. So this will cancel this, right? So from all these calculations, we get this very strange thing, which probably doesn't answer the question, right? But OD is this. I can understand you're a little confused because you're thinking that we need to find the angle. We are only finding the length. Okay, but let us see. Yeah. So OD is this. Is it okay so far? Right. So if OD is this,
Yes, sir.
right, then you can simplify and you will get that it is this. Just rationalize and whatnot. 2 minus root 3. So here is the situation. Okay. We forget everything else and we focus on this situation. Okay. This is 1 and this OD is 2 minus root 3. You need to know the angle. Any idea? Any guesses? Maybe no. Fine. So here maybe we'll learn something new. So this is a problem where maybe slightly new knowledge is needed. Okay. This is where a little bit of trigonometry comes, but let's see. We will see it a little bit. Situation is like this, right? You have a right triangle only. Okay. You know the ratio of the sides, like you know the side lengths, perpendicular and base, let's say. You want to find the angles. That is the task. Suppose I asked you another question. Suppose I told you that this was 1 and this was 1. Okay. In this case, can you tell me the angle? I'm asking a different question. Just
45 degrees.
45 degree. That's easy, right? So this question mark is 45 degree. So that's very easy. This question, this is similar to this question. I want you to see the similarity and then slightly more complicated. Now, if I change it and I ask you, I make this, let's say, root 3. Now, can you tell me the angle? So maybe I'll change the figure also because I want it to be root 3 slightly longer. This much is fine. Root 3. Now, can you think of what that angle should be? This is a new business, right? Like from this perpendicular and base ratio or even hypotenuse ratio will come. We want to be able to tell the angles. So you don't know, let's say, right? Then what to do? Can you tell me what is the hypotenuse length? Let's say you don't know the angle. Okay, fine. So what's the hypotenuse length?
2.
2. Okay, that's good. So sorry, that comes out to be 2. Now any ideas? So let's try to complete the picture. This reminds us of something. To me, it reminds me of an equilateral triangle somehow. I'll tell you, right? You want to complete the picture, you can complete it in any way you want. But it reminds me of an equilateral triangle, so I will try to make an equilateral. I'll just reflect this figure about this. Maybe like this. So you see what I've done. Just extend it figure and let's see if this leads us to any new understanding. I've just simply reflected from the top. Okay, so whatever this angle is, which we don't know, this is the same angle, and this side is 2, so this is 2, and this is 1, so this is 1. Now you see the full picture. Does it? You see, it's an equilateral triangle. We have completed the picture. Some new ideas, but still very natural, not something very strange. Do you see XYZ is equilateral? I made something more than what the question had. That's what we have to do sometimes. So XYZ is equilateral. Is that okay? You see, XZ is 2, right? This is 2. Any confusion?
No, sir.
Yeah. So it's okay. It's all 2. So it's equilateral. So now can you tell me what the angle is? Now it's an equilateral triangle, right? So everything is 60, 60, 60. That is something which you know, right? 60, 60, 60, and so this 30. You see, suddenly we now know the answer. Earlier we did not. See, it's just completing the picture. But don't worry, it's always not so complicated. We develop from here, we develop some formulas and so on, and that makes life easier. But this is the how it starts. It was not clear that it's 30, but now it is 30. Okay. So this kind of picture, we had this. Here also we have to do something similar, but maybe slightly more complicated. Okay. This thing is called, so this perpendicular by base, right? This ratio xw by wy. This ratio is called tan theta. Maybe tan is usually in smalls, right? So tan of whatever this angle is, tan theta. Okay. So this is, again, you might be thinking, now to solve this question, I'm going in so many different places, but I don't have a choice. I have to, okay, mostly. So you take any equilateral triangle, forget this and this. Tan, so whatever this angle theta is, right? This, with that angle theta, you get a triangle, right? And this ratio of perpendicular and base becomes fixed, right? Because any other triangle with this angle theta will be similar to this, right? It will be just an expansion of this. And so that ratio will remain the same. And so we call this tan theta. In this case, what is given to you is this ratio is given to be this, or what was initially given to be this. And you have to figure out what that angle is. This is a reverse problem. Okay. And yeah, now that is a little tricky. So what we have seen, well, tricky, but then there are some formulas. What we saw just now is that if this was 1 and this was root 3, then this becomes 1 by root 3. And we know for this case that theta was 30 degrees. Okay. Similarly, according to a formula, this, if this is 1 and this is 2 minus root 3, then this theta in this case becomes 75 degrees. But maybe right now we are not in a position to know that. Okay. Right. So next day I will maybe do a little bit of trigonometry formula. Have you ever done trigonometry so far? Any trigonometry?
Yes, sir, the formulas and all.
So this is where it is going, right? So you know, right, where tan 30 is 1 by root 3, right? Then you would know that formula.
Yes, sir.
So that's what. So when I gave you 1 and root 3, then you should know the theta is going to be 30 degrees, right? And for example, if I give you root 3 and 1, then can you tell me? Then it is 60 degrees, right? Because now the perpendicular base ratio is root 3. So tan of theta is root 3, so theta is 60 degrees. Okay, but this one you probably don't know, right? That tan theta equal to 2 plus root 3. What is theta? Do you know this? Probably don't know, right? That is 75 degrees. For this, we need to know how to manipulate these things. So you know the formulas, but maybe you don't know how to uh, find tan of 75 degrees and those things. Yeah? So I will discuss a bit that. Okay. So if you so what trigonometry have? So okay, whatever trigonometry you have done, I will just ask you to just go back and revise it a little bit, right? So maybe some NCRT book, some book, yeah. So there you just go and just have a look at the formulas, but that's okay. But solve the exercises, okay? I would request you to solve at least 10 questions, okay? So that you are fresh with the at least calculation side and so on. Then I will discuss how to find tan of, let's say, a plus b. So tan of 30 plus 45. You know tan 30, you know tan 45. How do you find tan of 30 plus 45? It is not, so this is obviously not tan 30 plus tan 45. Yeah, life is not so easy in that sense. It is not like this. We will have to understand what it is. Okay. This I will do next time. Okay. So we'll meet next Saturday and do a little bit of this trigonometry. Okay, and when we are not only what is needed, and I'll give you some questions, but your job is now to practice at least 10 questions for me. Okay, don't do the very easy ones, do the easy ones and 10 questions which are like last 10 or miscellaneous something. Okay, so find the right book. I don't know which grade 9 or 10th till whatever trigonometry I've done, then after that you can. Suddenly if you jump to very hard one, then it's no point. Okay, so that's it for today. We'll see you next Saturday. I'll be on time, 9:30. All right. Take care then. Good night.